So in this question, the curve have equation y equal to x squared plus 2 over x. So the first thing I can do is I can rewrite this as y equal to x squared plus 2x minus 1. Okay, now part 1, write down the expression for dy by dx and this. So first one, let's write dy by dx. So dy by dx will be simply 2x minus 2 over x squared, right? And then d2y by dx2, so d2y by dx2, that will be what? That will be 2. And this can also be written as what? This can be written as 2x minus 2, this. So multiplied by the power will be plus 4, and minus 1 will be minus 3. That should be 2 plus 4 over x power 3. This is part 1 of the question. Now part 2, we have to find the points of the stationary point on the curve and find its nature. So pretty easy. This happens when dy by dx is equal to 0. So equate, that will be 2x minus 2 over x squared is equal to 0. That is part 2 of the question. At the stationary point, dy by dx is equal to 0. Now, let me send this over here. You will have 2x is equal to 2 over x squared. Cross multiply, you will have 2x cubed is equal to 2. X cubed is equal to 1, so x have to be 1. Now, when x equal to 1, what is the y value? The y value will be replaced back in here. You will have 1 plus 2 over 1. That should be 3. So the point is 1, 3 for the stationary point. Now moving on, we have to find its nature. To find its nature, we have to use this one. So d2y by dx2 at the point where x equal to 1, right? This is the x value. Replace, you have 2 plus 4 over 1, that should be 6. Now because it is a positive value, we realize it will be a minimum point or minimum value. So because of that, right? That's question part 2. Now for part 3, we have to find the volume of the solid formed when the region enclosed by the curve, the x-axis, and the line this and this is rotated by the x-axis. Now again, we have to know rotation about the x-axis is always going to be, the formula is pi y squared with respect to dx. So in this case, let me find some space over here to complete the last question. So for example, we know that y is the equation of the curve, which is x squared plus 2 over x. Now we want to find the volume about the x-axis. So we know that about the x-axis, there's only one thing we can do, is using the formula, which is the volume have to be pi multiplied by y squared with respect to dx. So we know y. We have to find y squared, right? So let's find y squared. Y squared will be what? X squared plus 2 over x square this value. That should be x power 4 plus 4. So here you'll have 2 times this times this. That will be 4 over x times x squared, and then plus 4 over x squared. That should be cancelled out. As you can see, that will give you x power 4 plus 4x plus 4x power minus 2. This will be y squared. Replace back in the main equation. You will have volume will be pi integration. The limits has been given to you. It is the values of x between 2 and 1, right? So you have x power 4 plus 4x plus 4x power 2 with respect to dx. So step by step now, pretty easy. That should be pi is pi outside. Here we have x power 5 over 5, 4x squared over 2, and then you have to plus 4x power minus 1 over minus 1. Limits to 1. Simplify, pi is pi. So first replace 2, you will have 32 over 5. Let's see. 2 power 5 is 32, yeah. And then this will be obviously 2x. So 2 times 4 is 8. Here we have minus 4 over x, so minus 4 over 2. That's the first part, and then minus when x equal to 1, that should be 1 over 5 plus 2 minus 4 over 1. So let's see what do we have. So 32 over the value of 5 plus 8 minus 2. That should be 12. 2 over 5 minus, here we have 1 over 5 plus 2 minus 4. That would be minus 1/4. So 12 over 2 over 5 plus 1 over 4 over 5. That will be 14 and 1/5. Volume will be this times this, units cube for the volume of the shape that we are trying to find. And this is the last question of this paper. I hope this is somewhat helpful. As always, thank you for watching. I will see you soon.